to talk about the rational root theorem. All the rational root theorem does is it gives us a way to pick what we should divide our polynomial by. So currently, when you have a polynomial, I tell you what to divide it by to kind of give you a hint about what the factors may be. The rational root theorem allows you to figure out what to divide by on your own. So let's talk about this general polynomial. Here I have a general polynomial. Let our polynomial be ax to the n plus bx to the n minus 1. I realize that this notation may be a little bit confusing, so let me break it down for you. The a, b, e, f, g, and so on, those are all the coefficients. And this part, the x to the n, those are like the variable parts. So if we had an example, let's say, of 3x to the third plus 4x to the second minus 5x plus 10, then our a would be 3, and our 10 would be the g, the last guy. So all we're saying is that if we have this polynomial, the possible rational roots of the polynomial are the factors of the last guy over the factors of the first guy. Let's talk about what the word rational means. So rational just means that you can write the number as a fraction. We talked about this in the very beginning of the year. Often when you're solving polynomials, you get answers like this. X equals 3 halves, 0, 5. You could get something like plus or minus root 6. You could get something like 2 plus or minus I, for example. So these first 3 are rational, meaning that you can write them as a fraction. 3 over 2 already is a fraction, 0 over 1 is a fraction, and 5 over 1 is a fraction. However, you can't write the square root of 6 as a fraction. This is an irrational number. And the same thing with 2 plus or minus I. It's not a fraction. It's not even real. It's an imaginary number. So now all this theorem does is it gives us a clue about what the rational roots may be. It doesn't help us with irrational or imaginary roots. So what we're saying here is that the possible roots are going to be the factors of the last number. What numbers can multiply to make 8 over the factors of the first number? What numbers multiply to make 2? So all your job is in these problems is just to list out what the possible factors could be. We're going to start with that. So let's just talk individually about these factors. 8 factors into a few things. All I think you should do is just start at 1 and just go up and see what goes into 8. 1 goes into 8, 2 goes into 8, 3 doesn't, 4 does, 5, 6, or 7 doesn't, but 8 does. Now realize that it's not just these numbers, but also the positive or the negative of these numbers. For example, negative 8 and negative 1 multiply to be 8. Then let's talk about 2. The first number, the a. So the factors of 2 are just 1 and 2. Let's not forget our positive and negative. So now that we have the roots of the factors of the first number and the factors of the last number, let's try to take these and divide them to figure out what the possible roots could be. Remember that the theorem says that the possible rational roots are the factors of g, the factors of the 8, over the factors of a, factors of 2. So our possible roots are, what I would suggest that you do is just go through each number on the top and then just divide them by the numbers on the bottom. So our possible roots are plus or minus 1 over 1. 1 divided by 1 is just 1, so let's just write it that way. It could be positive or negative. Then we could have 1 divided by 2. So 1 divided by 2 is a half. Don't forget your plus or minus. So now we're done with that one. I just sort of crossed off to keep us organized. Let's move on to the 2. So now I have 2 divided by 1, which is 2. And then I have 2 divided by 2, which is 1. I already wrote him here, so I'm not going to write him again. Don't forget your plus or minus. I'm done with that guy. Now let's do this, the 4. So now 4 divided by 1 is 4, plus or minus. 4 divided by 2 I have already written there, so I don't have to rewrite again. So we're done with 4. Now let's move on to the 8. 8 divided by 1 is 8, plus or minus. 8 divided by 2 is 4. I already have that written. So here are our possible roots. So we're saying that if you divide this original factor by one of these roots using synthetic division, then you are likely to get something that works. If it's not one of these numbers, it won't work. For example, if you divide this polynomial by x minus 3, it's not going to give you a remainder of 0. These are the only guys that have the potential to give you the remainder of 0. They could give you a remainder of something other than 0, but these are the only guys that could work. This way you're not just stabbing in the dark when you're trying to find something to divide your polynomial by. However, this one is only a quadratic, so it would only have two roots, two rational roots anyway. So let's figure out what our roots are. Now, this is a quadratic equation. So we could try to factor it just by looking at it. So are there any numbers that multiply to 16 and add to negative 3? So nothing accomplishes that. So if you were going to solve this, you would have to use the quadratic formula, which would be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. All right. So now, if you look here, this inside this radical, you're going to get you're going to get a negative number. So I have 3 plus or minus the square root of 9 minus 64, which is negative 55 over 4. We can simplify this to be 3 plus or minus I root 55 over 4. So here were my answers here. The reason that this answer isn't one of the 10 answers that I had up here is because this is an irrational answer. Let's move on to another example. So let's talk about what the possible rational roots of this polynomial could be. Now, it's always going to be the factors of the last number over the factors of the first number. This one's a little bit easier because the first number is just 1. The only factor of 1 is 1, so that doesn't complicate things at all. So all we really need to do is list the factors of 12. Our factors of 12 are 1, 2, 3, 4, 5 does not go into 12, 6 does, 7 doesn't, 8 doesn't, 9 doesn't, 10 doesn't, 11 doesn't, but 12 does. So here are possible roots, possible things that could go into that polynomial. Just for fun, let's try to find out what these roots actually are. If I take this polynomial and divide it and factor it, which numbers multiply 12 and add to 13 is 1 and 12. So the roots of this polynomial are x equals 1, negative 1, and negative 12, which were two of my possible answers. Here I have negative 1 and here I have negative 12. What we're saying is that there's no way for you to get x equals 5 as an answer or x equals 7 as an answer. The only possible answers, rational answers, are the ones that we've listed. That's what the rational root theorem says. Let's try one more example. So here we're trying to find what could be the rational roots of this polynomial. It's always factors of this guy or factors of that guy. So our polynomial would be factors of 8. Factors of 8 are plus or minus 1, plus or minus 2, plus or minus, oops, not 3, that's 7, 4, plus or minus 8, over the factors of 3. Which is just plus or minus 1 and plus or minus 3. So all we're doing is taking the top guys and dividing them by the bottom. So 1 divided by 1 is 1. 1 divided by 3 is 1/3. Now we're done with the 1. Let's move on to 2. 2 divided by 1 is 2. 2 divided by 3 is 2/3. We're done with that guy. 4 divided by 1 is 4. 4 divided by 3 is 4/3. 8 divided by 1 is 8. 8 divided by 3 is 8/3. Now let's not forget all of our pluses or minuses. So if I were trying to divide this polynomial, I could just pick any one of these to get started with. So I know that this seems like a lot, it doesn't seem like this helps at all, but if you didn't have this theorem, you'd just kind of be guessing about what could go into this polynomial. So let's try this example. So what are the rational roots of, here we have something that's the third power, something that you really couldn't look at and just factor on your own. You'd have to have some clue. So it would be factors of 3 over factors of 6. So the factors of 3 are plus or minus 1 and plus or minus 3. The factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So now we're just going to take the top numbers divided by the bottom numbers. So 1 divided by 1, because it should be possible roots. 1 divided by 1 is 1. 1 divided by 2 is a half. 1 divided by 3 is 1/3. 1 divided by 6 is 1/6. Now we're done with the 1. Move on to the 3. 3 divided by 1 is 3. 3 divided by 2 is 3 halves. 3 divided by 3 is 1. I already have 1, so I'm not going to rewrite it. 3 divided by 6 is 1/2. I already have that. I'm not going to rewrite it again. So now, plus or minus, all the way around. Everybody gets one, even if I can't write it. And now all we're saying is that the possible roots are these guys. Typically what you would have to do to figure out which one they are is just try to plug numbers in. I would take 1 and plug it in using the factor theorem. If I took 1 and plugged it in and I got 0, I would know that x minus 1 was a factor. Well then, if it didn't work, if I got 5, let's say, I would move on to the next one. Plug in -1, plug in a half, plug in -1/2, and you would go until you found one that worked out, that gave you 0 as a remainder. But because that is very tedious, I'm going to give you guys a shortcut. I'm going to be very nice to you and allow you to just look at the graph. So I have the graph here for you. So if you look at this graph, you can see that this polynomial has 3 zeros. The zeros are located at each of the spots where our polynomial crosses the x-axis. So these first two look like they're fractions. You can use them, but they're fractions. I know you guys don't like fractions. This third one is a whole number. It's 3, positive 3. So positive 3 is one of the ones that will work. Now that you know that 3 works, you can take x minus 3 and divide it into your polynomial. So let's say x minus 3 and divide it into 6x cubed minus 17x squared minus 4x plus 3. Let's see what we get. I would suggest that you do this using the synthetic method. So I'm going to rewrite this as 3 in our little box, 6, -17, -4, and 3. Bring down the 6, multiply, add, and we get a remainder of 0. We better get a remainder of 0 because it was a 0. It does go unevenly. So now we know that this remaining polynomial is 6x squared plus x minus 1. Now, if I want to factor this further, I can do it just by looking at it. What two numbers multiply to 6 and add to 1? Multiply to -6. Those two numbers are -2 and 3. So I can rewrite this polynomial as 6x squared minus 2x plus 3x minus 1, and then do my factor by grouping. I know that this is a long problem, but you guys are getting smarter, and as you get smarter, the problems get longer and longer. So 2x plus 1, 3x minus 1. So my answers are -1/2 and 1/3, which agrees with what your graph has here. It looks like this could be -1/2 and this could be positive 1/3. So now I have all of my rational roots. If you realize that -1/2 and positive 1/3 and 3 were all listed in my original list of possible roots. So it worked. I have a joke for you. I think it's a good one. So did you ever hear about the astronaut who stepped in gum? He got stuck in orbit. All right, guys, do not forget to answer the questions. If you do not answer the questions before the bell rings, I will not give you credit.